Visual storytelling is more engaging and descriptive than text-based narratives. The rise of digital technologies has broadened its scope, offering new genres and diverse delivery methods. As these technologies evolve, the key question is, what's next for visual storytelling, and how can it create novel experiences? One strong candidate we want to study is immersive technology. Immersive technologies like 360-degree videos show promise but often limit user control. Major news outlets use interactive formats like mobile AR, but they typically lack multi-scene transitions. We aim to expand multi-scene journalistic storytelling to immersive environments for deeper engagement. Specifically, we explored how people perceive and navigate 3D spaces. Readers can experience stories from exocentric or egocentric viewpoints, moving either actively or passively. Our goal is to understand how these design choices impact spatial immersion and comprehension in immersive VR stories. As an initial step, we did a formative study involving 3 steps. We first collected stories from major news outlets. We then filter out those without significant 3D spatial information, as they are not suitable and informative for our study. Finally, we conducted an elicitation study with 3 VR experts. In summary, experts frequently mentioned 4 major story components in the responses: main visual elements, story narratives, navigation trigger, as well as visual and text guidance. Based on our formative study findings, we developed 2 egocentric and 2 exocentric story cases, each with active and passive versions. One egocentric case is about the COVID virus concentration comparisons among 3 ventilation conditions in a classroom. This egocentric story consists of a classroom model with teacher and students. In each ventilation condition, a corresponding airflow will show up along with the narratives on audience's left controller. In active navigation, audiences first teleport to different positions to view the normal airflow in different angles, following the visual guidance like arrows and lines. Then one infected student is introduced, and audiences are asked to open the window and put on the fan to change the ventilation condition, which leads to different concentrations and distributions of contaminants in air. In passive navigation, audiences click a controller button, and the visual elements are changed automatically. The virtual environment is moved. In the first-person view, it is as if audiences were moved to corresponding positions. The field of view is reduced during movements to alleviate motion sickness. Another egocentric case is about the Tulsa massacre. This story is built as a neighborhood with an avenue and buildings on the 2 sides. Following the web-based story, each building is labeled with the businesses before the massacre, and some of their owners have introductions on the panel. In active navigation, audiences follow the arrow, teleport to the hotspot in front of a building, and read the corresponding narratives. They repeat this step until they reach the end of the neighborhood. In the passive navigation, audiences click a controller button, and the neighborhood will automatically transform itself. The field of view reduction is also used in this case. One exocentric case is about the impact of climate change on the Gulf Stream in the Atlantic Ocean. The main visual element is a globe with animated currents. The story walks audiences through the Gulf Stream. In our active immersive story, audiences grab and rotate the globe to look at a series of designated points of interest. The directions they should rotate to and look at are indicated by 2 arrows. In passive navigation, audiences click a controller button, and the globe will be translated and rotated automatically so that the corresponding point of interest is facing towards audiences. The other exocentric case is about how 9/11 reshapes the financial district of Manhattan. A 3D landscape of Lower Manhattan is shown in front of audiences. Similar to the previous case, audiences also manipulate the landscape with grab and rotation as the active navigation. But in this case, the guidance is a translucent ghost landscape animating from the current transform to a desired transform. In passive navigation, audiences click a controller button, and the landscape will be transformed so that it is facing towards audiences with the desired angle. We finally conducted a within-subject user study on 24 participants to evaluate the performance of spatial immersion and understanding among different settings of viewpoints and navigations. Results show that the exo and ego viewpoints showed advantages in content and spatial detail memorability, respectively, but it is not statistically significant. We also found that active navigation enhances the sense of presence compared to passive navigation. It does not greatly increase workload when combined with ego viewpoint. Participants also demonstrated a preference on either ego plus active for its higher agency and engagement, or exo plus passive for its higher focus on the content. Our study indicates the associations between viewpoints and navigation and provides a preliminary exploration of their individual and combined effects on VR storytelling, which could benefit future immersive storytelling designs.